Hi, I'm Callie. Today I'll be speaking about what we've learned in chemistry in quarter 2. So there are three main topics, about kinetic particular theory, acids and bases, and solute and solution. So first I'll be speaking about the kinetic particle theory. So before we started this, the first thing we did was balancing equations, but we didn't really go into it, but I'm still going to talk about it. Basically, balancing equation is making the reactant and the product equal, an equal number. So for example, if it's 2Mg plus O2, the answer will be 2MgO because magnesium is 2 and oxygen is also 2, so it's equal. So kinetic particular theory is the next one. In kinetic particle theory, we learned about diffusion rate. My notebook is here, so I'm looking down at it. It's diffusion rate. So diffusion takes place faster in gases because the particles in gases are more apart, so it's easier for the particles that are being diffused to go through. But in liquids, it's harder for them to go through because the liquids are closer. And in solid, diffusion doesn't actually happen. So lighter particles diffuse more rapidly because of the rate of diffusion. And the thing that says that the lighter particles diffuse faster than heavier ones is relative molecular mass. So, example, salt diffuses faster than sugar in water, in liquids. And then the states of matter, there are three sets of matter: solid, liquid, and gas. And if you change the temperatures, it changes. If you increase the temperature from solid, you can change something from solid to liquid because it will melt. And another thing is kinetic molecular theory. This talks about the ideal gases. Ideal gases have no volume and they have elastic collision. They're always in constant and random motion. They don't attract or repel each other, and have an average kinetic energy directly related to Kelvin temperature. Also, we talked about pressure. Pressure is measured by barometer. Basically, there's mercury in a tube or a glass, and the mercury rises as the temperature of the atmosphere pushes it down, and then you can see the pressure of whatever you're trying to measure. So the next one is the ideal gas formula, or the ideal gas equation. The ideal gas equation is, it's PV equals nRT. So P is pressure, V is volume, N is the number of moles in a gas, R is the constant. So the constant is 0.0821, sorry. T is temperature, and I already said P is volume, and P is pressure, and V is volume.